Hi everyone, in this video we'll be talking about relational expressions, and in doing so we're laying some very important groundwork for what's to come in the weeks ahead. So let's begin. This discussion really has to begin with what we call the relational operators. I'm sure you've seen these before, even if it's been a while, but we have our less than and greater than operators. Less than or equal to, an operator like this would read less than or equal to, and I'll make a note that there's no space in between these two operators here. We have greater than or equal to, that's an easy one, and not equal to. So basically, relational expressions use relational operators, these guys, to determine how one value relates to another. So here's an example of a relational expression. 3 is less than 4. That expression states how the number 3 relates to the number 4. It's less than in this case. Another relational expression, 4 is greater than 3. Okay? And it doesn't have to be numbers. Notice I said how one value relates to another. That could be a numeric value, or it could be something like this. If I asked you to, grab your printed schedule from Moraine and tell me what the course code is that course code equal to MIS 105? So that's an example of a non-numeric relational expression. So basically, I think students instinctually understand this. The major problem, if any, is getting the sign straight with the greater than or less than. So I'm going to give you a tip on how to always keep the sign straight in our next slide. Okay, here we have a relational expression. We saw this on the previous slide. 3 is less than 4. Okay, now you just remember that the alligator always turns to the bigger meal. All right, so he's turning away from the 3. Therefore, the 4 is the greater of the two. So we could say 3 is less than 4. We could also read this as 4 is greater than 3. So if you think of that, that relational operator, that arrow, as an alligator with open jaws, you can really never go wrong. Okay, so let's read some of these relational expressions in plain English. This first one here, we would say x is less than y. Why is x less than y? Well, the alligator is turning away from the x, so it must be less than y, right? We could also read that as y is greater than x. Okay, a is greater than b. Look at the way the alligator is turning towards the a. Okay, here we apparently have a variable. Okay, well, these are variables too, but age is greater than or equal to 21. School equals MVCC, non-numeric relational expression. School is not equal to U of I. Okay, and then we have Schmidt is less than Smith, and you can compare string values. We call these strings when you have a string of characters all together contained in quotes. You compare string values with a computer much the way we would alphabetize names if we were making an alphabetized list. Okay, so here's another thing about relational expressions. Relational expressions evaluate to either true or false. Okay, what do we mean by that? Well, here's an example. Let's say we have a program. Somebody is prompted to enter a driver's age. Let's say this is for a driver's license facility. And we read that number from the console, okay, and put that number into age. And then we have to determine whether or not to give that driver a driver's license based on his or her age. So here's our relational expression in yellow. If age is less than 16, then we're going to deny the driver's license because you have to be 16 to have a driver's license. So our relational expression here will either evaluate to true or false, depending on what the person's age is. Okay, so once this executes, if this were a real program, once this line executes, I'm standing there with either a true or false in my hands, so to speak. If it is indeed true, and I have a driver under 16, then we will indeed deny the license. Okay? Here's another example. Okay? If somebody wants to get into a nightclub, enter the patron's age. We enter the patron's age. We have another relational expression. Okay? If age is less than 21, then we're going to deny them entry to the club. So this relational expression in yellow will evaluate to either true or false. And depending on whether it ends up true or false, we'll take any given action from a choice of actions. Okay. We can also use words and or to construct what we call compound relational expressions. And this is a lot like constructing compound sentences in English. Okay? So for example, I have a compound relational expression here, which kind of mimics a real life example. And here's the first one. If homework status equals done, if that's true, okay, and house status equals clean, okay, so we have a compound relational expression. We're evaluating two conditions, really. Is my homework done? Is my house clean? Yes or no? Then if both of these end up being true, both of these conditions, the homework is done and the house is clean, then I'm going to kick back and relax, okay? Or else I'm going to get to work and start doing some of the things I need to do. So there we have a compound relational expression. And the and or, when they're used in this way, those are referred to as the logical operators. So you saw the relational operators, the greater than, the less than, and so on. And or are often in programming referred to as logical operators. Okay, here's another example using logical or. Let's say we have a young person, very young person, trying to get into an R-rated movie. Okay, if age is greater than or equal to 17, if this is true, it's a non-issue. We let the person into the R-rated movie. Okay? Or if they're with a parent, then they get entry into the movie. Or else we'll deny entry. So really only when you have the or, the difference with the and the or, with the and, both of the conditions need to be true in order for the whole thing to evaluate to true. If my homework is done and the house is clean, both of those things need to be true in order for me to be able to kick back and relax. If one of those is false, meaning I have a dirty house or the homework isn't done, then I've got to get to work because there's work to do. Now with the or, only one of your relational expressions in the compound relational expression needs to be true. Okay, so either we have somebody who's of age, 17 or older, and that's true, they'll get entry into the movie regardless. Or, you know, if that happens to be false, and I have, say, a 13-year-old, if they're with a parent, then they also will gain entry into the movie because only one part of this needs to be true because it's an or. It's just like in plain English. It really operates just the same way.